Hello everyone. Today is I'm going to have a pre-recording for you for this second workshop, especially just on the theories, and as the others I will cover during our workshop. Yeah, let me share screen with you. By the way, I hope you have been started your assignments. And if you have any questions, you can ask me in the group. Yeah, just give me a moment. Okay. All right, so this is this is a development theories on approaches to mathematics. Yeah. Okay. Wait. Hold on, Eva. All right. Never mind. Okay. So learning outcomes will be upon completion of this lesson. Students should be able to identify theories, practitioners in mathematics, outline the cognitive development theories of mathematics, discuss Piaget's stages of cognitive development, describe constructivist and traditional approach to mathematics learning. Okay, what we're going to learn today, concept learning, naturalist experience. Okay, informal learning experience, structural learning experience. So you will see that these few things will be repeating also, because mainly these are the ways that uh, we teach children, or how children can learn. Yeah, theories will be constructivism theory. Okay, let's make it bigger. All right, Dini's theory, Montessori's theory, Maturini's theory, behaviorist theory, information processing theory. I will be talking about theories too, concept learning, and also the approaches to mathematics learning, constructivist approach and traditional approach. What would it be the difference? Understanding mathematics concept. It is an understanding of an idea or thought. Something that can't be taught directly is something each and every person comes to understand at his own. You come in contact with that situation, and it's how you come to learn that, oh, this is a concept. This concept is this. This concept is this. All right. And also based on dominant theories such as Piaget and post-Piaget and information processing. All right. So these are the concepts, and concept is something that as they come in encounter with the learning, encounter with the the problem solving, so to speak, the encounter with the situation. That's where they learn the concepts of mathematics. Yeah, plus, minus. Okay, why is that plus? Because it's adding. They finally come to realize, okay, shapes, more or less, big, small, tall, thin. Okay, conservation and all this. These are all the things they will learn uh, when they come in encounter with it through their experience. Yeah, skill. Okay, an activity that can be learned and that can improve with practice. A skill is something that you have to do, okay, in order for you to improve. Is observable and measurable. It's something that they can watch, they can observe, and it is measurable how good they are the first time. now how good they are now. Okay. Example, counting skill. Okay, arithmetic, addition, subtraction, multiplication, if there is. Okay, mathematical vocabulary. Okay, what are the mathematical vocabularies? They are plus, minus, divide, all right, equals, right, things like that. And then also problem solving, which is most of the time is in a storytelling form. So it's problem solving. Then you can write the numbers. They learn to write, that is a skill. And reading numerals. Okay, reading numerals. So they can read it. Okay, so you see they are the 5 domains involved also actually. They read, okay, they say the words, there is language, writing, okay, there is hand-eye coordination, building up the physical fine motor muscles, yeah. You see, and then they learn problem solving, which is intellectual, okay. And what else they learn? So these are the things that is in conjunction with the 5 developmental domains. Okay, they got intellectual, they got physical, mainly is here, right? Concept learning. In order for children to learn about concepts, they need to learn that they are objects. Yeah, I think it's also again a repetition from the first one. They are objects, these things they can see, they can touch, something that's tangible. All right. Learn that objects are still there even when they are not visible. The concept learning is they tend to remember and know, oh, even though now the things are not there, I still can picture that the thing is there. In order for that means I understood the concept. Learn that objects have names and have differences. Okay, all objects are different and can be same, can be different, and they have a name to it. No characteristics of the objects. Okay, that means, okay, this object is long and thin, all right, short, or this object is round, okay, things like that. And then to know how to use the objects, okay, how to use it, okay, what to do with it. Concepts are acquired through the 3 learning activities, which is naturalistic experience, informal learning, and structured learning. Yeah, naturalistic environment, which will be experience will be something they learn naturally. Okay, informal will be is very much linked to the naturalistic, and then it's just very informal, it's not structured, it's not planned for, that's why it's informal. And the structure would be something that is planned for, like in the classroom. So naturalistic experience is takes place through the children's day and in a range of situations. Does not take place only at set learning times. Yeah, it is just any time, okay, of the day where they tend to have time to learn. What the adults do, what the adults do is to uh, provide the environment interesting enough to get the children to use all their sensory motor to learn mathematics. Experience that are initiated spontaneously by children as they go about their daily activities. Yeah, it's very spontaneous learning. What time is it now? Or it was 1 o'clock just now. Now it looks like it's 2. 1 plus 1 is 2. Example. Okay. Uh, uh, how how fast did you run to over there? It took me 1 minute to run from here to there. Example 1. Okay. So that's how they learn. It's a spontaneous learning, naturalistic. Major mode of learning. Major mode of learning for children during the sensory motor period. Yeah, can be a valuable mode of learning for older children also. Yeah. Anyway, we are talking about natural realistic experiences, things that come naturally as on a day-to-day basis. Informal learning initiated by the adult when the child engaged in a naturalistic experience. When they come to something natural, like I said just now, oh, what time is it? It's 1 o'clock. Just now it was one. Now you see it has to go more, add one, two. Okay, it's informal learning. Okay, so engage in natural experience. These experiences are not pre-planned. Okay, informal is not planned. That's why it's informal. Help children draw more meaning through scaffolding. Informal learning experiences occur when an opportunity for instruction presents itself by chance. It's just by chance you get to teach them 1 + 1 is 2. It has to be more. Structured learning is something that you prepare for. You have a lesson plan. Structured experiences are pre-planned lessons or activities. These activities can be carried out with a large group, like in a classroom, or a small group, or individual, or a special time. Okay, a special time that we have agreed upon or planned for, allotted for. Yeah, suggested that these be integrated with other learning activities. In learning mathematics, realizing it or not, uh, there is a, there is always the main focus, and without realizing we have um, integrated learning together. Okay, and again they will follow this cycle. Like you see, they will start from awareness. They suddenly realize, oh, I can count, for example, and then they start to explore, right? Find out more things, and then once they find out things, they start to ask more questions, and then once they understand it, they start to make use of it, utilize it. That is a cycle of the learning sequence. Yeah. So now, theorist cognitive development relate to mathematics learning. Yeah. Jean Piaget's cognitive theory, Vygotsky theory, Jerome Bruner's learning theory. Okay. So let's go through and see Jean Piaget's cognitive theory. According to Jean Piaget's, uh, there are 3 types of knowledge children gain in their early years. Okay. Their physical knowledge involves an understanding in concrete way rather than abstract terms like how objects and materials behave in physical world. Physical learning is something concrete, something tangible. They can see, they can touch, they can feel. Okay. Logical, mathematical knowledge about relationships between objects through the use of comparison and seriation. Okay, the relationship between this and this. Okay, there are 5 oranges here, and then they see another 5 objects. These two they say is the same. Why same? They can compare and see they are the same. All right, so and they are okay, and or another way is the 5 oranges, and they see a 5 there. So these 5 oranges is in relation with this number 5. Okay, they are related. Social knowledge, knowledge about the world that can only be transmitted socially, such as labels for objects. Okay, social knowledge, how they learn, they saw these numbers all over the kindergarten, for example, 1 to 100. So they saw it, or they walk by um, a shop whereby they sell all these number plates, they sell number, saw the numbers there, for example. So it's a social knowledge from the labels they learn. Just like also we learn from language, whereby all the labels they put chair, table, pen, all these labels, they are learning from it. Likewise, this uh, just say social knowledge, yeah, is outside socially. 4 stages of cognitive development by Jean Piaget. So the sensory motor stage is from 0 to 2 years old, whereby they use all the 5 senses to learn. They use all the 5 senses to make sense of what they are learning. using sensory to construct knowledge and understand the world, to make sense of the things around them. They sense, they touch, they feel. Okay, to make sense of the things around them. They touch, they feel, oh, there's one milk bottle next to me, only one. Okay, for example. And then pre-operational stage is from 2 years to 7 year old. 7 years old, children still are not able to understand the concept of conservation. They cannot make up why this class, uh, earlier they are the same, but when I fall to discuss, it looks more. Why they cannot make it? They will just say that one has more. Okay, because they are at the operational stage. Symbolic thinking, they are only thinking symbolically, they are thinking of representation. They can only think they have something to represent what they saw. Okay, and then they're beginning to reason out. Okay, so example, they know the number 2 is this, but when they saw a duck, oh, it's like number 2, the duck looks like number 2, so it's a representation. Concrete operational stage is 7 to 11 years old, 7-11, understand reversibility concept and also conservation concept, able to classify, reason with logic. Just now we said 2 to 7 years old pre-operational stage, they cannot they cannot understand conservation. But when they reach 7 to 11, they can understand conservation. This cup, when they pour into their glass, even though it looks small, they are the same. Okay, they have the same amount of water, all right, same volume or whatever you want to call it. They are the same, or the length of the ribbon, even tied up, they are the same length. Okay, that is conservation, because at that point of time they already can think that way, think more logically. They are able to classify things. Okay, and they are able to reason with logic better. So formal operational will be the 11 years and above. Yeah, they are formal already. They know things better. Okay. Sensory motor stage 0 from 2 years old. The infant constructs an understanding of the world uh, around them, as I mentioned just now, with physical actions, things they can feel and touch. All right. Action at birth to the beginning of symbolic age, which is 2 years old. 2 to 7, as I mentioned. When they are 2 to 4, they gain ability to represent mentally an object that is not present mentally. And 4 to 7 use simple reasoning and want to know answers from all sorts of questions. That's the reason why they start asking a lot of questions from 4 to 7 years old. 2 to 4, they already can representing mentally. When they come to 4, they start talking, they ask you lots of questions non-stop. Why this, why that, yeah? Concrete will be, yeah, as mentioned, the child can now reason logically, okay, about concrete events, classify objects into different sets, yeah. This is all square, this is all circle, this is all triangle. They are able to do that. Formal will be the adolescents reason uh, in more abstract, idealistic. Okay, they are more mature, they can see things abstract, they can think abstract, they can do maths abstract, yeah, abstract maths, capable of engaging in hypothetical deductive reasoning. Okay, they can start to think, okay, how is this done? Okay, they can see abstract in their mind. All right, Lev Vygotsky. Okay, natural development, cultural development. Natural development influences learning. Okay, as a result of the maturation. As they mature, they can learn better, they understand things better. Okay, this is very true of Lev Vygotsky. And cultural development results from interaction with other members of the culture and enhance with the use of language. Okay, they start to talk to other people, they learn language. Okay, they learn interaction. All right, more, and understand things better. So Lev Vygotsky is talking about the ZPD, zone of proximal development. Alright, term for tasks too difficult for children to master alone, but can be mastered with an assistance. That means just a child, just with them alone, certain things they cannot learn more than what they can at their age. So you need an adult to help them so they can understand better. Just like you already know what is early childhood, but do you know in depth? So that's why you need to come to the university to learn. Same. Okay. Jerome Bruner, learning modes. Okay. This is learn through experience. Uh, inactive, learn through movement or action. Yeah. And active, play with book. Okay. After playing with the book, they tend to understand or to open the book is flip, for example. Flip one page, flip second page, flip. I reach the last page. How many pages do I leave? 10 pages maybe. So they learn through their own experience. Iconic, learn through images or icons. They see and they learn. All right, they see, they remember, they learn. Okay, they look at the pictures. Oh, it's like this one, huh? Classification means this one, all the oranges here, all the apples here, for example. Symbolic, learn through abstract symbols. They are read for research. They don't see the things they have to do abstract. They start thinking. All right. They have to use a lot of their logic and thinking skills. Stages of intellectual development in active mode, physically doing maths by manipulating. When a child learns about the world through actions on physical objects and the outcomes of the actions. Okay, they do something, and then from the experience they learn the outcome. It is how they learn from whatever they can touch and the outcomes of these actions. All right, oh, I do this is what the outcome. So the 3 to 5 years old under Jerome Bruner doing mental maths by thinking in terms of memories of visual, auditory, kinesthetic clues, where learning can be obtained through using models and pictures, okay, through icons, through things, they can learn better. Symbolic, 5 to 6 years, okay, this Jerome Bruner symbolic is 5 to 6, whereas symbolic for Jean Piaget is 2 to 7 years old, but it's inside there 5 to 6, 2 to 7. Yeah. Of course, the symbolic part is more on the later part. Yeah, the beginning part is they learn to know. After that, they ask a lot of questions and they follow. Able to use number symbols meaningfully develops the capacity to think in abstract. Okay, that's what Jerome Bruner says. Based on these three stage notion, Bruner recommends using a combination of concrete, pictorial, and symbolic activities will lead to more effective learning. So this is where we talk about they start to learn concrete and then they start to represent by drawing themselves, and then they use the symbols, which is the numbers, abstract. They don't see the thing anymore. They don't even see the picture they draw anymore. It's abstract in their mind, the numbers only. They only see the numbers. So you see here Jerome Bruner's 3 learning modes. Uh, so you can see 4 plus 5 equals how many, right? So you can ask the children to count. Let's count together. How many chocolate bars are there? Say, for example, 1, 2, 3, 4. How many? 4. Plus, how many here? 1. Let's count together. 1, 2, 3, 4, 5. So that 4 plus 5 is how many? Let's count together. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's how you teach them. You have to show them one by one. You know that doesn't mean the children knows. Okay, do it singly, one by one, so that they will follow you how to count one by one. Some may already know, the matured ones. Some do not know. So you have to benefit the best of both. All right. Okay, Zoltan Diniz. Yeah. 6 stages theory of learning mathematics. Okay, you have free play, generalization, comparison, representation, symbolization, formalization. Okay, they are kind of almost linked to what we learned earlier, like Jean Piaget. Okay, all right. I won't go through this video. Okay, free play is what? Trial and error. Activity free experimenting. You let them have the free play. You give them the things and let them do. Self-correcting. Okay, they learn by themselves. Just now, self-correcting is things they can learn by themselves and then they correct by themselves. Like puzzles they cannot fit, they will change it. Uh, the blocks where they can fit the stick into it, the which size stick to which block, yeah, which hole, yeah, things like that. So it's a self-correcting play, yeah, solving puzzle, okay. Then more systematic problem solving behavior becomes possible. So from there they develop a problem solving behavior. They know how to think better, they know how to articulate better. So what about stage 2, generalization? Okay, the rules of a game. You generalize the rule of a game. You're supposed to do this, do this, do this. Okay, recognizes patterns. Okay, regularities. Okay, common attributes. Everybody must follow. You cannot do on your own. Okay, you invent rules. There is a rule to the game. The comparison part of it. After playing a few games, can start comparing and discuss the different games. Oh, after playing, they know how to start it. Oh, this is like that. This one is not like that, for example. Similar rule structures, but different materials. Okay, this will encourage children that the material used for playing the games is less important than the rule structure and the objective of the game. Yeah, the material rule used is not important. It can be anything, but the rules are important. Okay, the rules are important. So yeah, this is what I'm talking about. Um, yeah, you just have to follow the rules and the rigid thing. So representation and mapping, yeah, using diagrammatic representation, arrow, diagram, table, coordination to help children to map the abstract idea of the games. Yeah. So you see, first you can see here is 3 apples plus 3 red apples plus 2 green apples. Okay, 3 red buttons plus 2 green buttons. So you have 1, 2, 3, 4, 5. You ask to count, and then you have 3 plus 2 equals 5. This is the abstract. Okay, mapping. Symbolization. These are all the symbols of mathematics. Use formulas and words to describe a relationship. Okay, look at the map representation and see what properties must the game have. Yeah, so can see that. Okay, the symbols plus minus, okay, things like that, equals formalization. So symbolization stage could be very long and repetitive, like in a maze, so need to have a certain order. First few descriptions are axioms, yeah, axioms plus deductions are theorems, yeah, theorem. So equals the way to get the axioms and theorems are proved. Okay, let's continue here. I think the line was not very good just now. So now we will come to the approaches of maths learning. The other theories, you can read it up. All right. Approaches of maths learning, constructivist. Let me see, the recording is still on. Okay. Constructivist approach. The constructivist approach is a view based on Jean Piaget's work that suggests children don't passively receive knowledge through being taught, but rather actively construct it themselves. So children need to be actively involved. Okay, I always yeah, understanding. Okay, the line is back again. The line is not very good these days, today rather. Okay, there are stages of development concerning growth and cognition in sequential order. Yeah, they have to learn sequential order. Understanding of maths involve internalization of concepts and relationships. Okay, the line is back here. Hopefully finish up this for you. So children learn in a unique way, okay, with personal interactions and integrated with different approaches. Yeah. Okay, now I come to this final. Traditional approach, we always do drilling for children. Drilling means every time we keep on repeating and repeating. Every day we come back, we keep repeating. And then the learning is passive. Okay, but it's not so bad. After all, we make it until today. Yeah. So we have worksheets, we do a lot of activity, we have a lot of worksheets, yeah, doing work rather than just rather than the this approach whereby different learning approach, yeah, uh, whereby they use a lot of manipulative activities for them to manipulate their mind and learn better. Okay, so individuality is by uh, whereby this activity matters to learning. Uh, the approach is very much to individual. We let them see what's best for them. Okay, and the traditional approach is quite intimidating. adults and teachers. Okay, they tell the children, you must do this, you must do this. Yeah, so that is the difference. All right, so that's all for this lesson. All right, so I thank you to understand better. Bye bye. See you again.